you have. Let us start the revision of Unit 2, large sample test. You know that small n stands for sample size, capital N stands for population size. Whenever the collected sample is of large in size, whenever it is greater than or equal to 30, all those samples are called large samples, and the tests based on them are called the large sample tests. So we know that whenever n is very large, all the distributions, say binomial, Poisson, and all these, it tends to normal distributions. As n is very large, we know that either binomial or Poisson or any other distribution will approach to normal distribution. So here we are going to make use of central limit theorem to make the decision to accept or reject the null hypothesis. Let us see, you know the basic steps in conducting a test. What are these? What are they? Framing the null hypothesis, alternative hypothesis, sample data, test statistic, sampling distribution of the test statistic, critical value, two-tailed or one-tailed test, and decision. These are the major steps, whether those are non-parametric or parametric tests we are going to follow. Framing the null hypothesis, alternative hypothesis, writing the test statistics, its distribution, one-tailed or two-tailed, and decision. Now, what are the list of tests you are going to read under large sample test? Under large sample test, you are going to read, the first one is nothing but test for single mean, and here only test for difference of means. Second test is nothing but test for single proportion and test for difference of proportions and test for difference of standard deviations and jet transformation. These are the 5 tests you are going to read. Let us see the first 2 tests here. Now you should describe the nature of the sample before writing the test procedure here. Now whenever it's a test on single mean, name itself tells that you are going to describe only one statistic or one parameter, means you are going to collect only one sample for this. Let us say that you should describe the sample data first. For that, let us say that x1, x2, so on xn. These are common steps for any test under large sample test. x1, x2, xn is what is the sample size here? Of size n, drawn from a normal population with mean mu comma variance sigma square. Whenever x means here x is a sample from n comma mu comma sigma square. Now next step you need to write the null hypothesis. What is the null hypothesis there? We indicate null hypothesis with H naught, as this is test for single mean. As this is test for single mean, here whenever here single means you are going to talk about only one statistic or one parameter. Here you are going to write that, you should write in literally and also symbolically, that is there is no significant difference between population mean and sample mean. Just listen here first. Before going to that, try to understand what are the population constants called. Population constants are always called the parameters. Those of sample constants are called statistics. Here population mean we indicate with mu and that of sample with x bar. Population variance with sigma square, that of sampling variance with s square. Population proportion with p, sample proportion with p, and sample this with r and this with rho. Now you should to write the test statistic, you know the standard errors of this. What is standard error of x bar? Sigma. If you know this, writing the test statistic is very easy. SE of x bar is sigma by root n. Then what will be SE of x1 bar minus x2 bar? For difference you will get sigma under root, you will get sigma 1 square by n1 plus sigma 2 square by n2. What is SE of p? Which is nothing but root over pq by n, where q is nothing but 1 minus p. What is SE of standard error s? Sigma by root over 2n. So these are the standard errors of mean, proportion and ST. Now coming to our test for single mean. Here it is, this is the test for single mean. The null hypothesis will be there is no difference between the population mean and sample mean, or we write that as mu stands for population mean. Its specified value always we'll write with mu is equal to mu naught. What will be the alternative hypothesis? There is a significant difference between population mean and sample mean. Means mu not equal to mu naught, which is nothing but two-tailed test. First describing the data, writing the null hypothesis, writing the alternative hypothesis. Now to write the test statistic, what is a test here? It is a test for single mean. As this is a test for mean, you should write the sampling distribution of the sampling mean. If this is the test for proportion, you should write the distribution of p. If it is a test on r, correlation, you should write the sampling distribution of sample correlation. So here you should write the distribution of mean, the corresponding estimator of mu is x bar. So you should write x follows normal with mean mu. You should write the square of this, which is nothing but sigma square by n. You should write the sampling distribution of x bar, which is nothing but x bar follows normal mu comma sigma square by n, using the central limit theorem under large, all these are large sample test. Under large sample test, using central limit theorem, always the test statistic we are going to write with z, which is equal to, what is the test here? It is for test for single mean. So you are going to write single mean x bar minus z. How do you define? Z is equal to x minus e of x by root over variance of x follows n01. So here in place of x you are going to get x bar minus e of x bar by root over variance of x bar follows n01. As you know that the first parameter stands for mean, second one for variance. So z will be x bar minus, what is e of x bar here? Mu by, what is, you need to consider this or directly standard error of x bar, which is nothing but sigma by root over n follows n01. So this is the test statistic for testing H naught. So z is equal to x bar minus mu by sigma by root over n follows n01. Here next, what is the next step here? After writing the test statistic, you should consider the table value z alpha. In general, we will consider as z alpha by 2 if it is a two-tailed test, z alpha if it is one-tailed test. Let z alpha by 2 be the, as we are considering this is a two-tailed test, the table value will be z alpha by 2. Z alpha by 2 is the table value at alpha percent LOS from areas of which distribution? Standard normal distribution. You will compare z with z alpha by 2, as all these are large sample test. Mod z greater than z alpha by 2, you are going to reject the null hypothesis. Otherwise, you are going to accept the null hypothesis. This is test for single mean. The second one is nothing but test for difference of means. Difference of means a minimum of 2 you should have. So you should describe about 2 samples, that x1, x2 so on, xn1 be first sample, y1, y2 so on, y1 be second of size n2 be another sample drawn from 2 populations. Let this be drawn from a normal population with mean mu1 comma variance sigma 1 square. This is drawn from another population mean mu 2 comma variance sigma 2 square. As this is test for difference of means, you are going to collect two different samples from two populations with the corresponding parameters. Now after describing the data, you should write null hypothesis. What is a null hypothesis? Null hypothesis always a hypothesis which shows a neutral in neutral. That is, here always you will start with the word call. There is no significant difference between the two means. Difference between the two means. That is H naught such that what are the two means here? Mu1 comma mu2. So mu1 is equal to mu2. What is the null hypothesis? There is a significant difference between the two means, which is nothing but mu1 not equal to mu2. So in the previous test, just we wrote the distribution of x bar. As you have two means here, try to describe what is x1 bar. X1 bar is nothing but sample mean of the first sample. X2 bar is nothing but mean of second sample. Now let S1 square be its variance and S2 square be its variance. Means here mu1 mu2 are the population means, x1 x1 bar x2 bar are the sample means. Sigma 1 square sigma 2 square population variances, these are sample variances. How do you write here also? You will indicate the test statistic with Z. Moreover, how do you define Z? Always x minus e of x by root over variance of x follows n01. As that it is the test for difference, in place of a simply x bar, you are going to get x1 bar minus x2 bar minus e of x1 bar minus x2 bar by root over variance of x1 bar minus x2 bar follows n01. So here x1 bar minus x2 bar. What is E of x1? E of x1 means expectation of x is always mu1. So E of x1 is nothing but mu1 minus mu2. Under root you will get variance of x1 bar plus variance of x2 bar. This is x1 bar minus x2 bar. Since mu1 is equal to mu2, under h naught you are going to get mu1 is equal to mu2. The second term will be 0. But what is variance of x1? You should write the sampling distribution here. x1 bar follows normal with mean mu1 comma sigma 1 square by n1. x2 bar follows normal with mean mu2 comma sigma 2 square by n2. You will get sigma 1 square by n1 plus sigma 2 square by n2 is the test statistic. I think here you will have three cases, when these are unknown and when these are known. This is the known case. When those are unknown, you are going to replace s1 square by n1 plus s2 square by n2. When you have a common one, you are going to write sigma into, under case 2 you will get as x1 bar minus x2 bar by s1 square by n1 plus s2 square by n2. When those two samples, when sigma 1 square comma sigma 2 square are unknown, when they are drawn from the when they have the common variance, you are going to write that as x1 bar minus x2 bar by sigma by root over 1 by n1 plus 1 by n2 follows n01. When this sigma is unknown, you are going to estimate that with n1 s1 square by n1 s1 square plus n2 s2 square by n1 plus n2. So again you will calculate z value. You will compare mod z with z alpha by 2. Less than means you are going to accept the null hypothesis. When it is greater than z alpha by 2, you are going to reject the null hypothesis, where z alpha by 2 is the table value at alpha percentile wise. What we have discussed here: test for single mean, test for difference of means. Here you should describe only one sample from one population, x1 bar, and these are the corresponding variances. Writing h naught, mu is equal to mu naught. Writing h1, mu naught equal to mu naught. As this is for single mean, you will write the distribution of x bar with using the standard error. Mean always mu and square of standard error here using central limit theorem. X bar minus e of x bar by se of x bar follows n01. Decision you know. mod z greater than z alpha by 2 reject, otherwise accept. Here you should describe two samples of two different sizes n1 comma n2. You write this with n mu1 sigma 1 square and mu2 sigma 2 square. You should describe what is x1 bar is the sample mean of the first sample, x2 bar is the mean of the second sample, s1 square is the first sample variance and second sample. Next you should write h naught. As this is for difference of means, you are going to compare two means, mu1 is equal to mu2. Here mu1 not equal to mu2, z will be x1. As you have only one, you got x1 x bar. Here you will get x1 bar minus x2 bar minus e of x1 bar minus x2 bar by 2. Variance of x1 bar minus x2 bar follows n01. These are the three cases. Acceptation and rejection is same for both the tests. Thank you.